Today's problem is intersection of linked lists. This is on InterviewBit. And so you can pause the video here, go over to InterviewBit, and try this out, intersection of linked lists, and then come back and we'll walk through the solution. So this is rated as easy. Let's see, asked at Amazon and Microsoft, write a program to find the node at which the intersection of two singly linked lists begins. For example, the following two linked lists begin to intersect at node C1. Okay. Yeah, we'll come back to that. If the two linked lists have no intersection at all, return null. Linked lists must return their original or retain their original structure after the function returns. You may assume there are no cycles anywhere in the entire linked structure. Your code should preferably run in O of n time and use only O of 1 memory. Okay, we can do that. So this isn't, I mean, there's one insight here that helps with this. And what we're going to do in order to solve it is we're going to take the first list, list A, and we're going to concatenate list B to the end of it. And we're also going to, I mean, we're not physically going to do that, but conceptually that's what we're going to do. We're going to take linked list B and concatenate A to the end of it. And then we're going to start a pointer at the beginning of each list, and we're going to go through until either we find the same node or well, until both pointers wind up on the same node, or until both pointers are null. Now both pointers, if they go to null, they're going to go to null at the same time because we've constructed two lists of the same length. We've got A plus B, we've got B plus A. There isn't anything here that says whether or not that either of the linked lists can be null to begin with. That would be a good question to ask if there was somebody to ask. If you got this in an interview, you would want to ask, is it possible for one or both of the lists to be null? We don't know that, so we'll handle it as an edge case. But let's look at this. Let me get a pen here. So let me show you what happens if we concatenate B to the end of A and A to the end of B, and we go through both lists. Now, let's start going through list A. All right, so this will be the first node that we get to. 1, 2, 3. Okay, there's the intersection node. That's the third node. Now we're going to miss that on the first try through B because we're not going to get, going through B, we're not going to get to it until the fourth node. But we'll keep going here. 1, 2, 3, 4, 5. And at that point, we go to the head of B, and we get 6, 7, 8, 9. All right, so we hit that C1 at node 9. All right, get rid of those. What happens when we go through B? We've got 1, 2, 3, 4, 5, 6. That's the end. So now we go to the beginning of list A, 7, 8, 9. Okay, so on the ninth node, we do hit that C1. And the reason that we hit it the second time through is if we concatenate both lists, if we concatenate B to the end of A and A to the end of B, then each of those lists, these are going to be the last three nodes. So if we miss it the first time, and there is an intersection, we do have the nodes, the intersection and all the nodes after the intersection will be nodes in common to both lists. So If there's an intersection there, we will find it using that method. All right. Let's look at the implementation. Now this first thing here, if A is null or B is null, return null. I don't know if either of these lists can initially be null, so we'll put that in and catch it. We've got A pointing to list, we got pointer A pointing to list A, we got pointer B pointing to list B. Now we've got a while loop. While they are not equal, now they're going to be equal either when they hit the same node or when they both hit null. And in either case, it will drop out of the loop. Now, if there is no intersection and they both go null, drop out of the loop, and we'll return the pointer. It doesn't matter which one, really. I said pointer A, but they're going to be equal, so it could be pointer B. If there's no intersection, it'll return null. So what we're going to do with pointer A, we are going to go from pointer A to pointer A dot next. I don't think we looked at the list node. There is a list node class, but it's not going to surprise you that it looks like every other list node class. It has a value and it has a pointer to the next node or null at the end of the list. All right, so for pointer A, we'll go through it. We'll go to pointer A dot next until pointer A equals null, at which point we'll set pointer A to the head of list B. Same thing on pointer B. We're going to follow pointer B through pointer B dot next until pointer B equals null, and then we are going to set pointer B to the head of list A. And in that way, each pointer will traverse both lists. Okay, I think that's all that there is to be said about it. Let's run it and see what happens. Actually, let me get rid of the annotations over there. All right, thanks for watching. This is a two-pointer problem. I mean, you could say it's a linked list problem, but saying that it's a linked list problem doesn't really help you solve it, but identifying it as a two-pointer problem will help you solve it. So if you found this helpful, hit like, subscribe, check the playlist on screen. There's a lot more videos there to help you keep improving your interview skills. The video description and the pinned comment has a link to free coding interview patterns PDF. There's 12 of the most common coding patterns that are asked in coding interviews, including the two pointers pattern. So you can grab that. It's free, and that's it. We'll see you next time.